So hope you have all watched the recording of the first session, the 7.1 exercise we had finished. If you have not done, please do watch that because this is related. That introduction is very important. The conditions of how two triangles can be congruent, right? We had done all those conditions, SAS, SSS, ASA, RHS, and so on. So if you haven't covered that, please do that and then come back to this session. So this is theorem 7.2. We need to do this theorem 7.2 before we proceed. That is, angles opposite equal sides of an isosceles triangle are equal. So if you are having a triangle which is isosceles, that means two sides are equal, AB and AC are equal. We have to prove that the angles opposite to them will be equal. That means we have to prove that angle B equal to angle C. So what is given to us is that this is isosceles. The sides are equal, AB, and we have to prove that angle B equal to angle C. So construction, we are drawing the bisector of angle A. So angle 1 equal to 2. So this is the construction. We are drawing the bisector of angle A and it is intersecting at this point D. And now we are going to take this triangle BAD and CAD and prove them congruent. So take the triangle BAD, CAD. AB equal to AC is already given. Angle 1 and 2, that is angle BAD equal to CAD by construction. We drew this because this is the bisector. And AD is common. If you look at the triangle ABD and if you look at this triangle ACD, you will find that AD is common. AD is part of both the triangles. So this line AD is going to be common. So what are we having? We are having side angle side. So triangles are congruent by SAS. And therefore, we can say that these two angles are equal by CPCT. So in the previous session, I had explained what is CPCT. It means corresponding parts of congruent triangles. So this proof is important. It can be asked in the exam. Prove that angles opposite equal sides are equal. And the reverse of this will also be true. If angles are equal, then the sides opposite to the equal angles will be equal, right? So the theorem says that if sides are equal, angles are equal. The converse says that if angles are equal, then sides opposite to equal angles are equal. And we'll be using both these properties when we are doing the second exercise. So second exercise, the first question, in an isosceles triangle AB equal to AC. So we will draw the figure here, AB and AC are equal. The bisectors of angle B and C. So bisector means, last time also I had explained, when an angle is divided into two equal parts, that is called a bisector. Angle is divided into two equal parts, that is bisector. So these OB and OC are bisectors and meeting at a point O. Join A2. So the figure is like this. We have to prove that OB equal to OC and AO bisects angle A. So let's start with the first one, how to prove that OB equal to OC. So first of all, let's number these angles 1, 2, and 3, 4. It is given to me that 1 equal to 2 and 3 equal to 4 because OB and OC are given bisectors. So bisectors of angle B and C are intersecting at O. So this is given to us. We can write that given angle 1 is 2 and angle 3 equal to angle 4. Now it is given to us that AB equal to AC. Now just now we did the theorem that if it is given that it is isosceles, here it is given isosceles, sides are equal, then angles opposite to them will be equal. So angle B equal to angle C. Angles opposite equal sides are equal. This is the theorem. If two sides are equal, then the angles opposite to them will be equal. So angle B equal to angle C. Now we did Euclid's axiom. If two things are equal, their half will also be equal. So half of B equal to half of C. And instead of half angle B, I can write angle 2. And instead of half angle C, I can write 4. Because they are bisectors. So if I half this full angle, I'll get one portion of that. So I can replace it with 2. And this half angle C, I can replace with 4. So 2 equal to 4. Now I told you that if angles are equal, the sides opposite to them will be equal. So we are going to use the reverse of this. So in triangle OBC, 2 and 4 are equal, proved. 2 equal to 4 proved. So in a triangle, if we know that if two angles are equal, then the sides opposite to these equal angles will be equal. and therefore we can say OB equal to OC. Okay, sides opposite equal angles are equal. So 2 and 4 are equal, so OB equal to OC. So this is the first part. Now to prove AO bisects angle A, that means I need to prove 3 equal to 4. I will prove the triangle AOB and triangle AOC congruent. I will prove the triangle AOB and AOC congruent. So how can I prove that? One condition is already given, AB equal to AC. This was given to us. 3 equal to 4 has to be proved, right? So don't take that. OA equal to OA is common. And if you look at this OB equal to OC, we have already proved this here in the first part. In the first part, OB equal to OC is already proved. So we have AB equal to AC given, OB equal to OC proved. And look at the triangle AOB and AOC. AO is common for both. Common. So we have 3 sides of the one triangle equal to 3 sides of the other. So we can say the triangles are congruent by SSS. Triangles are congruent by SSS. And if triangles are congruent, then we can say that the angle inside that, the corresponding angle 3 equal to angle 4 CPCT. So 3 equal to 4 CPCT, or in other words, we can say AO bisects angle A. AO bisects angle A. So you can note down this. The first part we had proved by using the property that if AB equal to AC, then that half will be equal. Angle B equal to angle C, the half B equal to half C, 2 equal to 4. If 2 and 4 are equal, OB equal to OC. Second part, we are proving by congruency, SSS. Therefore, 3 and 4 will come equal. And if 3 and 4 are equal, then we can say that AO is bisecting angle A. Then we'll go on to question number 2. The diagram is already given. Please note down the figure. It's a very simple question. AD is given perpendicular bisector of BC. Perpendicular means this is 90-90. Okay, both of them are 90. And it's a perpendicular bisector. Bisector means division into 2 equal parts. So BD and CD are equal. Show that the triangle is isosceles. We have to prove AB equal to AC. So very simple. We just need to take the triangles and prove them congruent. Take triangle ABD and triangle ACD. And what are our 3 conditions? First condition, it is given to us that this is a perpendicular bisector. If it is a perpendicular bisector, then bisector means BD and CD are equal. These 2 sides are equal. And these angles are equal. ADB and ADC, both are 90 degrees. So this is given to us. And one condition, if you look at ABD and ACD, both has got AD. AD is part of both the triangles. So this is common. So we've got 3 conditions, side, angle, side. So we can say that triangle ABD is congruent to triangle ACD by SAS. And if the triangles are congruent, then AB equal to AC by CPCT. Corresponding parts of congruent triangles are equal. So we will get this equal. So that's answer number 2. Very simple question. We can prove them by SAS. Question number 3. Figure again given. ABC is isosceles triangle. The figure is given here. ABC is isosceles. That means AB equal to AC. Altitudes. Altitude means 90-90, right? BE and CF are drawn to equal sides. AB and AC. So AB and AC are equal. Show that these altitudes are equal. Altitudes are equal. That means I want to prove that BE and CF are equal. I need to prove these 2 equal. So what am I going to do? I'm going to take triangle ABE and triangle ACF. These are the triangles I will take, ABE and ACF. Look for the conditions in ABE and ACF. What are the things which are equal? That I'm going to see. So already it is given to you that AB and AC are equal. So condition number 1, AB equal to AC. We are looking at these 2 triangles, right? ABE and ACF. AB equal to AC. And then we see here this is 90. So we can say that angle AEB, this particular angle is 90, and this particular, we are looking at the triangles AEB angle is 90 because this is 90 means linear pair. This is also 90, right? Perpendicular is not on one side, it is for both sides. So AEB is equal to AFC equal to 90. So AEB and AFC are equal. Now we need one more conditions. For that, look at the triangles. You will find that angle A is common, whether you take ABE or this triangle ACF. ABE or ACF, A is common for both. So angle A equal to angle A common. Therefore, triangles are congruent. ABE is congruent. Well, how is this congruent? See here we have two angles and one side. So here, if I look at this triangle ABE, we have angle, angle, and side. So triangles are congruent by AS. And if the triangles are congruent, then obviously the altitudes BE will be equal to CF. So BE will be equal to CF, CPCT, right? Question number 4, they have changed the conditions. That's all. Almost identical proof. So here it is given to you that altitudes BE and CF are equal. So here it is given to me that BF equal to CF. There we have to prove that B equal to CF. And now we have to prove the triangle is congruent and the triangle is isosceles. So the triangles that I'm going to take is same, only conditions will be different. So I'm going to take triangle ABE and ACF as mentioned here. I cannot take AB equal to AC because that's I have to prove that. But what is given now is that the altitudes are equal. So BE will be equal to CF. Okay, BE will be equal to CF. And again, these are altitudes. That means these two angles are again 90. So angle AEB is equal to angle AFC, 90 degrees. This is ABE and AEB and AFC are 90. Yes. So second condition. And now we need the third condition. For that, again, if you look at the triangles, angle A is common. So only one condition has changed here. So again, if I look, what condition is this? Look at this. Angle A was common and angle E is equal to F. And third condition, we have got BE equal to CF. Again, it is angle, angle, side. Triangles are congruent by property of AAS, angle, angle, side, angle, angle, side. And therefore, we can say AB equal to AC, the second part by CPCT. And we know that if two sides are equal, the triangle is called isosceles. So therefore, this is related. AB equal to AC, that is ABC is isosceles. Okay. So question number 3 and 4, except for one condition which is different, the procedure is totally same. Then we go to question number 5. ABC and DBC are isosceles. So these two sides are equal, these two sides are equal. Question is prove that ABD, this full angle and this full angle are equal. So if these two sides are equal, I can say angle 1 equal to 2. Just now we did the theorem, right? If two sides are equal, angles opposite to equal sides are equal. So 1 equal to 2 and BD equal to CD. If two sides are equal, then 3 equal to 4. And now just add up. So I'm just writing this AB equal to AC given. Therefore, we can say angle 1 equal to 2. Let's take this as equation 1. BD is equal to CD, again given to us. Therefore, we can say 3 equal to 4. Now, we can add both. We will get 1 plus 3 equal to 2 plus 4. We are adding 1 and 2. And if you look at 1 and 3, what will we get? Angle ABD. And if you add 2 and 4, what will we get? Angle ACD. So here we have proved ABD equal to ACD by using which property? Angles opposite equal sides are equal. Angles opposite equal sides are equal. We are using this property. So here we have two sides equal, so angles are equal. Here also same, and then we add up. And when we add up, we get the required result that ABD equal to ACD. Then let's do question number 6. This you can mark importance. Figure is already given. Side BA is produced such that AD is equal to AB. So these two sides are equal, and it is already given that AB and AC are equal. So these two sides are equal. And what we need to prove that this is 90. It's a right angle, means it is 90. So AB equal to AC given. And just now we did that if sides are equal, angles opposite to them will be equal. So we can assume these two angles are equal. So angle ABC is equal to angle ACB equal to X. Angles opposite equal sides are equal, right? So these two angles can be denoted by X. Now AB is also equal to AD and AB equal to AC. Both are given. Now Euclid axiom says two things equal to the same thing are equal to each other, isn't it? If I have two things equal to the same thing, AB is equal to AD, AB is also equal to AC, then we can say that AC and AD are themselves equal. We can say that AC and AD are themselves equal. And therefore, if AC and AD are equal, the angles opposite to them will also be equal. So we can say that angle ACD equal to ADC. Both can be represented by Y. Right? AC and AD are equal, sides are equal, then the angles opposite to them will also be equal. So ACD equal to ADCY. Now we will take the full triangle BCD, and we know that angle sum property, all these angles together will end up to 180. So I can say that B plus C plus D is 180. Sum of angles of a triangle. Instead of B, I can write X. Instead of C, if you look at C, it is made up of two small angles, X and Y together. So I will replace C with X plus Y, and angle D is represented by Y. So when I solve this, I'll get 2x plus 2y is 180. I will take 2 common, I will get x plus y, 2 bracket x plus y 180. Therefore, x plus y is 180 by 2, therefore x plus y is 90. So we get angle BCD is 90. And if we say that BCD is 90, then that means angle BCD is a right angle triangle. So question number 7 now. 7 and 8 are easy questions. ABC is right angled at A. So just make a right angle triangle, right angled at A. So it's like this. This is 90. AB and AC are equal. So these two sides are equal. Question is find angle B and C. So just now we know that if sides are equal, the angles opposite to them will be equal. So if AB and AC are equal, then angle B equal to angle C, right? Angles opposite equal sides. And if the sides are equal, we can assume them both to be equal to X. So B and C are equal to X. Now this is already given 90. So in triangle ABC, use angle sum property now. We can say that 90 plus X is 180, isn't it? Sum of angles of a triangle is 180. We know this. And when we add this, now what we'll get? 2x and 90 will be transferred to that side. 180 minus 90, so 2x is 90. So x will be 90 upon 2, which is 45. Therefore, the question was find angle B and C. So both these angles B and C will be 45 degrees each. Then we have question 8. Show that each angles of an equilateral triangle are 60. Now, what is the meaning of an equilateral triangle? Equilateral triangle is a triangle in which all the three sides are equal. So AB equal to BC equal to CA given. If the sides are equal, then angles will also be equal. So we can say that A, B, and C are equal, and we will assume to be X. Angles opposite equal sides are equal is the theorem. Angles opposite equal sides are equal. So if all the three sides are equal, three angles will be equal. So we are assuming the three angles as X. Now in triangle ABC, again using the same property, sum of angles of a triangle is 180. So we can say that x plus x is 180. So 3x is 180. X will be 180 upon 3. So x will be 60. And therefore, the question is show that each angle or every angle of equilateral triangle is 60. So if x is 60, that means all the angles A, B, and C are 60 degrees each. So these are the 8 questions of 7.2. And now we go to 7.3, which is the last exercise. Seven point three, we will be starting. And please do go through the solved examples, they are important as well. So we'll be starting with 7.3. Yes. So 7.3, question number 1, ABC and DBC are two isosceles triangles. That means AB and AC are equal, BD and DC are equal, isosceles. Prove that triangle ABD and ACD are congruent. So this is very simple because already two conditions are given to us. So take triangle ABD and ACD. AB is equal to AC given. BD and CD are also equal. BD equal to CD given. And what is the third condition? Look at ABD and ACD. You find that AD is common. AD is part of both the triangles. So AD equal to AD common. So we can say that triangles ABD and ACD are congruent. Look at the conditions. All three are sides. So triangles are congruent by SSS. So this is the first part, direct. Now we have to prove that triangle ABP and ACP are congruent. So AB equal to AC is 1. And if you look at ABP and ACP, AP is now common. And just now we proved that ABD and ACD are congruent. These two small triangles are congruent. So I can say 1 and 2 are equal CPCT. And this can be used as a condition now for the bigger triangle ABP and ACP. So ABD and ACD we have proved, and 1 and 2 we will say CPCT and we'll use it for the next. So take now the bigger triangle ABP and triangle ACP. Okay. AB equal to AC, again condition number 1. And now as I said, 1 and 2 we have proved just now. We can use it now. Proved. In 1 we have proved this and we can use it here. So angle 1 equal to 2 and AP is common. AP equal to AP common. So we've got three conditions. So triangles are congruent by which condition? Let's see. This is side, 1 and 2 are equal, angle, and there's a side, angle, side. So triangles are congruent by SAS. So we get ABP and ACP congruent by SAS. So second part done. Now we have the third part, AP bisects angle A as well as D. So AP is bisecting angle A, that we have already proved, 1 and 2 are equal. Now we have to prove that AP bisects angle D. That means we have to prove this 3 and 4 are equal. So for that we will take the smaller triangle BPC and CPD. Take the smaller triangle BPC, this triangle, and triangle CPD. If I am able to prove these two triangles congruent, then only I can say that 3 equal to 4. So BD equal to CD, that's one condition we have, right? Because this is already given to us. So we are taking triangle BPD. Triangles that we are taking. Triangle is BPD, okay, and triangle CPD. We are taking the third part. First two done. BPD and CPD, okay. So here we need to prove 3 and 4 are equal. So for that we are taking this. So BD and CD are equal. BD equal to CD given. Okay. DP and DP are common. DP equal to DP common. DP equal to DP common. And in the second part, we had proved that ABP and ACP. We have already proved ABP and ACP congruent. So BP and CP are corresponding parts of these congruent triangles. So BP equal to CP. This is CPCT of 2. We have already proved ABP and ACP. So obviously BP and CP are part of these congruent triangles. So BP equal to CP. So we can say now we have got three conditions. So triangle BPD is congruent to CPD. BPD congruent to CPD. How are we getting that? By SSS. all the three sides, BD equal to CD, BP equal to CP, and DP equal to DP common. So once we prove this triangle is congruent, we can say 3 equal to 4. So if 3 and 4 are equal, 1 equal to 2, we had already proved. So 1 equal to 2, 3 equal to 4. Therefore, what can we say? That AP is bisecting angle A as well as angle D. AP is bisecting angle A as well as D, because 1 is equal to 2 means AP bisects angle A, and 3 equal to 4 means AP is bisecting angle D. So this is the third part. Now, fourth part, we have to prove AP is the perpendicular bisector of BC. So bisector we have already proved, BP equal to CP. Now we have to prove it's a perpendicular. So we can number this 5 and 6. We had already proved that these two triangles are congruent. Which triangles? BPD and CPD. BPD is congruent to CPD, proved. We have already proved this. So 5 and 6 are equal by CPCD. Now 5 and 6 form linear pair. So 5 plus 6 is 180. Okay, these two are equal and they are linear pair. So 5 plus 6 is 180. Therefore, what can we say? That 5 and 6 are equal to 90. If 5 and 6 are equal to 90, what does it indicate? It means that AP is perpendicular to BC. And we have already proved here that BP equal to CP. Proved. So we have proved it's a perpendicular. We have proved that it is a bisector. And therefore, what can we say? AP is perpendicular bisector of BC. So in the exam, you may get 1 or 2 parts. You may get the whole thing depending on the marks. But the procedure we need to understand. First two were direct congruencies. Third, we had to prove these two small triangles congruent. Then we got 3 is 4. Then we got AP as the perpendicular bisector of AD. And the last part, we first proved is 90. And bisector we had already proved. So AP is the perpendicular bisector of BC. Okay, let's try question number 2. AD is the altitude of an isosceles triangle. ABC, altitude. Altitude means 90 of an isosceles triangle. That means AB equal to AC. Show that AD bisects BC, AD bisects angle A. Very easy question. We have to just prove the triangle ABD and ACD congruent. So if you look at this ABD and ACD, what are the conditions by which we can prove the triangles congruent? So already it is given isosceles, so AB equal to AC given. And it is given altitude, so angle ADB is equal to angle ADC 90 degrees. Right? AB and AC are equal and 90. And we look at the two triangles, AD is common. AD equal to AD common. So the triangles are congruent by RHS because we have right angle, hypotenuse and side. So this is probably the first question where we are using RHS. Triangles are congruent by RHS. And now we have to prove that AD bisects BC. So BD equal to CD, CPCT. Because once the triangles are congruent, then the sides BD and CD will be equal. So if BD and CD are equal, then we will get AD bisects BC. Then we have to prove that AD bisects angle A. That means this angle is getting divided into 2 equal parts. So let this be 1 and 2. We can number it 1 and 2. So 1 and 2 are also equal by CPCT. And we know that if 1 and 2 are equal, then it means that this line AD is bisecting angle A. Okay. So that's question number 1, part 1. And this is question number 1, question number 2, part 1 and 2. Both the parts done. So both are based on congruency, in fact. Question number 3. The diagram is already given here. AB, BC, and AM are equal to PQ, QR, and PN. So AB is equal to PQ given. AM is equal to PN given, and BC is equal to QR given. And it is given to you that PQ it is given to us that AM and PN are medians. Okay, AM and PN are medians. Now, what is the meaning of a median? Median is a line drawn from the vertex to the midpoint of the opposite side. So if I say that AD is a median, it means it is a line drawn from vertex to midpoint of opposite side. That means BD equal to CD. Okay. So understand the meaning of the word median. So it is given AM, median. They have used this word, and median PN. These are medians. So it indicates that this line is dividing this into two equal parts. So BM equal to MC and QN equal to NR. Okay. Now first we have to prove the triangles, small triangle ABM and triangle PQN congruent. We have to prove the small triangles congruent. So already we have two conditions, AB equal to PQ given and AM equal to PN. That's also given to us. These two conditions are given. Now for the third condition, we can say BM equal to QN. This is not given, but we have to explain why BM equal to QN, because BC equal to QR given. This is given, this whole line. BC and QR are given, and therefore half BC is equal to half QR. We know Euclid's example. If two things are equal, their halves will be equal. So half BC equal to QR. And I told you the meaning of median. Median is dividing this side into two equal halves. So when I say half BC, I can replace it with BM. And when I say half QR, I can replace with QN, because M and N are what? Midpoints. They are dividing this into two parts. So half BC is BM and half QR is QN. So we've got three conditions, 1, 2, 3. So triangles will be congruent by SSS, because all three sides are equal. And now we have to prove the bigger triangles congruent. Now, once the small triangles are congruent, we can say that angle B equal to Q, CPCT, because B and Q are part of these small triangles. And we can use this as a condition for the bigger one. So take the triangle ABC and take the triangle PQR. AB is equal to PQ given. This is already given to us. We are taking the bigger triangle. BC equal to QR also given. Two conditions were already given. And just now we have proved that B equal to Q. This can be used here as a condition. So we have AB equal to PQ, B equal to Q, BC equal to QR. Two sides and one angle in between. So I can say the bigger triangles are congruent to each other by SAS. Two sides and one angle. So this is question number 3. Question number 4. BE and CF are two equal altitudes. So let's draw the figure A, B, C. BE and CF are equal altitudes. Altitude means this is 90, this is also 90. BE and CF are equal altitudes. So BE and CF are equal, and altitude means this is 90. Using RHS, now they have specified, use RHS, we can't use anything else. Prove that the triangle is isosceles. Using RHS, prove that the triangle is isosceles. So we are going to take triangle BFC, okay, this triangle here, and triangle CEB and prove them congruent. Again, look at the triangles that we are taking, BFC and triangle CEB, this triangle and this triangle, BFC and CEB. So in this, as I told you, these are altitude. So angle BFC is equal to angle CEB 90. This is already given to us. Condition number 1. BFC is equal to CEB 90. Then if you look at the two triangles, BC is common. BFC and BEC both has got BC as the base. So BC is common for this. And what will be the third condition? BE equal to CF. This was given to us. BE and CF are equal altitude. So BE equal to CF was given. This can be used. So we have a 90 degree. We have the hypotenuse equal and one side BE and CF. So as per the question, we have to prove this only by RHS. So we have proved the triangle BFC and triangle CEB congruent by RHS. Now once we prove the triangles congruent, we can say angle B equal to angle C by CPCT. Angle B and C are equal by CPCT. And we know that if two angles are equal, the sides opposite to them will be equal, right? Therefore, we can say AB equal to AC. Which theorem are we using? Sides opposite equal angles are equal. So angle B equal to angle C means AB equal to AC. So if two sides are equal, what can be the conclusion? Hence, we can say that triangle is isosceles. Hence, we can say triangle is isosceles. So this is how we prove the fourth question that it is isosceles. First, prove the triangle is congruent by RHS. And then we'll get angle B equal to C by CPCT, right? These are parts of the congruent triangles, corresponding parts of congruent triangles. And then we are again using the property that if angles are equal, sides opposite to them will be equal. So AB equal to AC. And if AB equal to AC, then we can say triangle is isosceles. So I hope you have done this. Question number 4, BEC for equal altitudes using RHS. So we prove the triangles isosceles. Now last question is left. That is question number 5. And question number 5 says ABC is an isosceles triangle in which AB equal to AC. AP is the perpendicular to BC. So this is 90 degrees. Show that angle B equal to C. We have to prove these two. Angle B and C are equal, right? So again, simple question. The triangles that we need to prove congruent, ABP and ACP here are very evident to us. There are only two triangles. AB and AC are already given to us. So that can be taken as the first condition. AB equal to AC given. And AP is given perpendicular. So these two are 90. Perpendicular means 90. So angle APB is equal to angle APC 90 degrees. So we have these two sides equal and this is 90. And third condition, look at ABP and ACP. We find that AP is common for both the triangles. AP is part of both ABP and ACP. So AP equal to AP common. So by which conditions will the two triangles be congruent? Triangle ABP and ACP will be congruent by which condition? So here we have a 90 degree and we have the hypotenuse equal and one side. So triangles are going to be congruent by RHS. And if the triangles are congruent, then corresponding angles B and C are part of these two corresponding angles of these congruent triangles. So angle B will be equal to angle C by CPCT. So with this, we finish this chapter and you can go through each and every sum, and if you are stuck up somewhere, you can replay also and understand the procedure of doing these questions. Thank you.